Hey guys, welcome back. So 11.4-Counting principles. There'll be a bunch of things in here you'll be using that require use of your calculator. So if you have to, please watch the permutation combination video on the TID4 calculator section first, and then come back to this. So a permutation is just simply a way to count how we're arranging elements in a certain order. The number of elements is called the permutation of the elements for this. And one way we can calculate this permutation, it's not the only permutation form, but one way is what's called the factorial symbol. That's the exclamation mark. So this is the idea where if I want to do 6 factorial, I'm doing 6 times 5 times 4, 3, 2, 1. It's all the consecutive numbers from that first number all the way down to 1 multiplying together. And again, the calculator video shows you where you can find this factorial symbol in your calculator, so make sure you are comfortable finding that. Now, if we're talking about the idea of distinguishable permutations, this is generally when we talk about arranging objects when there's things being repeated. This is n factorial up top. That's where the total number of object is. And then n1, n2, n3, and so on end up nk in general. Factorials multiplying together on the bottom individually, factorial. These are the ones that are repeated. We'll typically use this when we talk about taking the letters of a word and arranging it in how many different ways we could create that particular word into other things. So if there are no repeated letters and the bottom is just 1, so the top is just an n factorial, the permutation idea. And if there are a couple letters being repeated, that's now going to affect on the denominator. So we have the word seminar here. So we can see that there are 7 letters. So we would have a 7 factorial. And we're taking a look at each of those letters, and none of the letters are being repeated. So it's just simply 7 factorial. So you'd find the factorial button on your calculator, do 7 factorial, and you'll find your answer is 5,040. Very simple. If you look at the word connected, so this one has a couple letters that are being repeated. We'll see that the letter C is repeated twice. We see that the letter N is repeated twice. And the letter E is repeated twice. The O, T, and D are not repeated, so they're just single letters there. So we would have a total of 9 factorial because there's 9 letters. But on the bottom, there are 3 separate 2 factorials multiplying together, each for the letters that are being repeated. Now, for the most part with these kind of questions, you're going to find most words only have 2 letters being repeated. Some of them might have 3. So there's a couple quick factorials to recognize. 2 factorial is going to be 2. 3 factorial is going to be 6. So in a case like that, you can do a quick multiplication. Because rather than trying to type this into your calculator, which can get a little messy, plus a little annoying to do the factorial over and over again, you're better off doing 9 factorial divided by 8. Because if this is 2 times 2 times 2, the bottom's an 8. And then that would yield us a value of 45,360. All right, a couple other factorials to recognize for other, depending on what other might show up. 1 factorial is just 1. Also, 0 factorial is considered to be a 1. If there is no numbers, we just consider it to be a value of 1 there. And after that, then it's obviously multiplying numbers together. Now, what you talked about in middle school is probably the idea of combinations versus permutations. Whether or not when you arrange things in order, will the order actually matter? So, for example, A, B, C, B, A, C, if those are different, that's going to be a permutation. So an example of that would be, let's say these 3 people were running a race, and the first spot is first place, second spot is second place, third spot is third place. So obviously this would be a different finishing order if I move the letters around. So that would be a permutation in that case. If instead we were talking about, let's say we're still talking about the same race, but rather than worrying about the top 3 finishers, the first, second, and third, we're just looking at the 3 best times. So not caring about the order they actually finished, and it was just, okay, who had the 3 best times? These 3 people. If I say them in a different order, it's still the same 3 people. That would be a combination then. So it's all about figuring out whether or not the order truly matters or not. Now, your 2 main formulas, if you were to work it out by hand, the combination is NCR, n factorial over n minus r factorial times r factorial, whereas the permutation is NR NPR, and then it's just the same thing, but no r factorial on the bottom, just an n minus r. N is how many elements we have. So if we have like 8 people doing something, N is 8, and then R is how many of them we want to arrange. So it's like we had 8 people in a race. we want the top 3 finishers, first, second, and third place, we would then say it's a permutation. We would say it'd be 8p3. Whereas if we had 8 people running a race, and again, we just wanted the 3 best times, didn't really matter the order they placed in, that would be 8c3. And again, you'll be using your calculator to do these things. So as I said in the beginning, if you haven't watched the combination permutation calculator video, you really should stop this right here and go watch that, because I'm not going to show how the calculator works here. I'm just going to kind of say, okay, here's the setup, and then here's what the answer is supposed to be. So watch that so you can see me finding those tools in the calculator. So 7p5, again, you're going into your calculator, putting in the right spots. I'll show both ways if you have the 83 and the 84, how that looks on your screen. But we should be getting 2,520 when we do that. Whereas if we take a look at 16C10, again, going through your calculator, finding the correct options, typing it in, you're getting 8,008. Now, the combination one is going to be a little more useful for you for future. In fact, 11.5 is going to use the combination formula fairly often, so you should get pretty good with it by the time we get into that. But where this can also be done is with part of like a word problem where we have to identify the order mattering or not. Another example besides the races, talking about if you have a committee. So the combination would be if you just have a committee forms a group of people. They have no special order. They have no special roles on the committee. They're just simply a group of people deciding something. Whereas if they have special roles, president, vice president, secretary, treasurer, all that kind of stuff, that's more likely to be a permutation, because the order you arrange them in will be based off the roles, so therefore it changes if I change the order. So for these word problems, well, sentences really, I guess you can call it a word problem. You'll be identifying whether it's a permutation or combination, and then what the final outcome is going to be. So 10 students in a race. How many possible ways can you top 3 students finish? Again, as we've been talking about, top 3, we're looking at the actual order here. It is going to matter. So this would be a permutation, so it's 10p3. And that comes out to be 720. Whereas if we have this situation here, a group of 21 people need to take an elevator to the top floor. They go in groups of 7. How many groups can be created? Here, the order does not matter. 7 people go into an elevator. Whether whoever goes in first or last, it's still the same 7 people in the elevator. So the order would not matter. We would have to completely alter the whole elevator scenario and be like, okay, based on who goes in here first gets to be pushing the button, I guess we'll say, to go up. Then that would be a permutation, because then whoever goes first would matter, because they're having a certain role or a certain outcome be occurring. In general, if there is no role for that, then it's just going to be a combination. 21C7, we get 116,280 possible ways we could arrange all of that. All right, so our next topic is going to be what we call binomial expansion. We'll be expanding out expressions, and this is where the combination form is going to come into play, which is why we reviewed it here, and also the permutations in this context. So I'll see everyone next time for that video.